The strength of an acid is determined by its ability to donate hydrogen ions or protons to water. As we move through the topic, we are going to start using HA to represent acids. So HA is our acid reacting with water. It's an equilibrium reaction to form our oxonium ion and our anion. Okay, so that is our acid, and this is our conjugate base. A minus is the conjugate base, or the anion. And the stronger the acid, the further to the right this equilibrium lies. So for very strong acids, to all intents and purposes, we expect them to be fully dissociated or fully ionized in solution. Now we're going to simplify this, so we can just write this expression as HA for the acid, H plus A minus. So if the strength of an acid depends on the hydrogen ion concentration, we could just use concentrations of hydrogen ions to rank our acids, but the range is huge. It runs from round about 1 times 10 to the minus 1 mole per decimeter cubed, so brain freeze there, to around about 1 times 10 to the minus 6. So rather than working with such a vast range of numbers, it actually becomes easier to use a logarithmic scale. And this is where pH comes in, because pH is defined as being minus the log 10, this is usually just referred to as minus the log, of the hydrogen ion concentration of our solution. Remember, the square brackets denote concentration. So if I know the hydrogen ion concentration, I can figure out the pH, and vice versa, because the hydrogen ion concentration, my square brackets, would equal 10 to the minus pH. This is a logarithmic scale, which means that moving 1 point on our pH scale is the equivalent to a change in hydrogen ion concentration of to the power of 10. If you are not mathematically minded, and I am 100% with you at this point in time, then you need to start getting your head around all these expressions and equations. And more importantly, you need to practice with your calculator so you know which buttons you're pressing in which order to get the right answers when we move on to doing calculations, which is where we're headed next. Calculate the pH of a solution with a hydrogen ion concentration of 2.63 times 10 to the minus 3 mole per decimeter cubed. So pH equals minus the log of the hydrogen ion concentration. So that's minus log, and this is how you tap it into your calculator, 2.63 times 10 to the minus 3, and that comes out at 2.58. No units, logarithmic scales do not have units. Vice versa, calculate the hydrogen ion concentration for a solution of pH 3.7. So pH equals minus the log of the hydrogen ion concentration. So that means that 3.70 equals minus log H plus. And if I were to rearrange that, that would be the hydrogen ion concentration is equal to 10 to the minus 3.70. Figure out how to get that into your calculator and be confident with it. This is really important. So it comes out at 2.00 times 10 to the minus 4 mole per decimeter cubed. Simple. If you go back to your textbooks, there should be loads of these little practice questions so that you can get really familiar with using the expression both ways, commit it to memory, and also on how to use your calculator. Alternatively, if you head over to Crunch Chemistry, then there are plenty of worksheets and worked examples that you can use. Strong acids such as nitric acid, sulfuric acid, hydrochloric acid, we assume that in solution they are fully dissociated, which means finding the pH of a strong acid is very straightforward. We can see here that if it's fully dissociated, then the ratio of hydrochloric acid to hydrogen ions is 1:1. If it's fully dissociated, then the concentration of the acid must be the concentration of the hydrogen ions. So for example, let's say we were asked to find the pH of 0.01 mole per decimeter cubed hydrochloric acid. It's a strong acid, so the concentration of the acid equals the concentration of the hydrogen ions. And if I know the concentration of the hydrogen ions, then finding the pH is very straightforward because it is minus the log of H+, so minus the log of 0.01, and that comes out to be 2. So if I have a concentration of 0.01 mole per decimeter cubed hydrochloric acid, the pH will be 2. If this has been useful, hit the subscribe button, the effortless way to support your studies, and by clicking the link in the description below, it'll take you straight to Crunch Chemistry School, where you can access my free math skills course, complete tuition, and worksheets designed specifically to build your confidence and stretch you. Together we can do this.